All right, first order integrating factors. So today we're talking about first order linear ODEs, and we want to talk about how do we actually solve these things. And one of the key methods is what's called an integrating factor. So let me just remind you really quickly. Remember that a first order linear ODE looks something of the form a1 of t y prime plus a0 of t y is equal to some function of t, something along those lines, where a1 is not equal to 0. Okay, if a1 were equal to 0, then my derivative vanishes and I no longer have a differential equation. So I have something like that. Okay, that's what a first order linear ODE looks like. Now, what's the standard form? Okay, the standard form is going to be the following. Just take a1 and just divide it through the entire thing. So if I do that, I'm going to look something like y prime plus a0 of t over a1 of t times y is equal to f of t divided by a0 of t. Okay, now that's kind of clunky. I don't really want to write these as fractions the whole time. So what's better, and what you'll often see, okay, is something like y prime plus some function of t, p of t, times y is equal to q of t, something like that, where I'm basically just saying that's p and that's q, okay? So that's what we would call the standard form of a first order linear ODE, okay? Now, what's this whole business about an integrating factor? Well, the integrating factor says, look, once you get it in standard form, this is a key fact, okay? You cannot do this if a1 is not equal to 1, okay? So what you need to do first is get it into standard form. So if a1 is like t or sine of t, whatever, you got to divide through first, okay? But once it's in standard form, then your integrating factor, okay, your integrating factor looks something like this, okay? It's going to look like mu of t is equal to, you identify what p of t is. Now be careful, p of t has to have this positive sign in front. So if you have something that's like y prime minus 2y, then you got to take the negative into account. So if I look at p of t, that's this thing, and my integrating factor is literally just e to the integral of p of t dt. Okay? That's what the integrating factor is going to be. Now, rather than boring you with all the details as to like why this actually works, let's just go to an example and solve this ODE using the integrating factor. Okay? So here's our method that we're going to do for every single one of these. Okay? More or less. Okay? So here we go. Solution. First thing is this in standard form? And the answer is yes. The coefficient of my y prime is a 1, so standard form, check. Okay? Next thing I need to identify is what is p of t. P of t in this case is a positive 2t, in which case I'm going to say my integrating factor is mu of t is e to the integral of p of t. In this case, that's 2t dt. All right? Now I integrate the 2t, I get a t squared, so I'm going to get e to the t squared. And now you note, okay, you do not need a plus c, okay? Why do you not need a plus c? Well, I'll explain that in just a second, but if I did have a plus c here, the next step that I'm going to do with my integrating factor will show you that you don't need that plus c here. So let me show you what's going to happen. The next step is once you have your integrating factor, you go back to your standard form ODE and you multiply everything through by your integrating factor. So multiply everything through by e to the t squared. So I'm going to get e to the t squared y prime plus 2t e to the t squared y is equal to 3t e to the t squared, like that. Okay? So here's why I didn't need a plus c. Let's pretend I had a plus c there. What would e to the t squared plus c look like? Well, that looks like just exponentiation rules. Tells me it looks something like that. And e to the c is just a constant, so I'll call it something else. So I'll call it a, e to the t squared. Okay? So again, the a is only there because of if I did have a plus c. Now look, what did I do with my integrating factor? I went to my ODE and I multiplied everything through by my integrating factor. So I would have had an a e to the t squared plus 2a t e to the t squared y equals a 3t e to the t squared. Well, I can just cancel a on both sides. So why do I need the a in the first place? I don't need that. So I don't need the plus c when doing integrating factors. Okay? Now the beautiful thing, and the whole reason why this integrating factor looks so goofy as this e to the integral p of t dt, is because that is precisely what will turn this thing on the left-hand side equal to the derivative with respect to t of your integrating factor, which is e to the t squared, times y. Okay? And just as a sanity check, let's do that. Well, how would I do this? I would do the product rule. Okay, so it would be first term times derivative of the second, so e to the t squared y prime, there it is, plus second term y times the derivative of e to the t squared, which is e to the t squared times 2t by the chain rule. So the product rule tells me exactly I'm getting the right thing right here. Okay, and the right-hand side is what it is. That's just a 3t e to the t squared. Now remember, we're trying to solve for y, so I'm just going to integrate both sides. It's going to tell me that e to the t squared times y is equal to the integral of 3t e to the t squared dt. Okay, so now I have to evaluate this integral. Now how do I do that? It's a u substitution. So I'm going to go u equals t squared, du is 2t dt. Okay, so I need a 1/2 out front here. So this is really, what am I going to get? I'm going to divide by the 2, so I'm going to get 3/2 e to the t squared. Okay, just a quick sanity check. The derivative of this is what? 3/2 times 2t e to the t squared. The 2 and the half cancel, and I get 3t e to the t squared. I win. Now this one, you do have to have a plus c on the right-hand side. Okay, you do have to have that plus c. And now the last step is simply to just solve for y. So what would I get? I would get y of t is equal to, if I divide everything by e to the t squared, those are going to cancel. So I'm left with 3/2 plus constant divided by e to the t squared. Well, that's the same as constant e to the minus t squared. Remember, exponents, when you have a negative, they go in the denominator kind of thing. Now, the biggest mistake that I see here is a lot of times people will look at this and they'll be like, oh, it's just constant times something, so it's got to be another constant. It's like, well, that's only true if you're multiplying by a constant. Okay? E to the negative t squared is not a constant function, so do not get in the habit of just calling that a new constant. Okay? So that, my friends, is how you use integrating factors for solving first order linear ODEs. All right? If you like the video, you have other examples, anything along those lines, post them down in the comments, like, subscribe, all the things. We'll keep going.